In this video we're going to take a look at finding the convolution of two functions. You can see in red the definition of convolution. You can see we can compute it in either of two ways, which are essentially the same. Those just show that the convolution actually is a commutative operation. In blue is the formula for the Laplace transform of a convolution. What it shows is that the Laplace transform of a convolution of two functions is the product of their individual Laplace transforms. And that's something we proved in class. So let's take a look at a specific example. Suppose I want the Laplace transform of the integral from 0 to t of 3 times t minus tau squared sine of 2 tau d tau. So we can see that the integral we're looking at is definitely a convolution. So the task here really is to figure out what the functions f and g are. If we look at this part right here that I'm bracketing with red, that's our function f of t minus tau. So f of t minus tau is 3 times t minus tau squared. So if I want to know what f of t is, I simply replace the t minus tau with just t and get f of t equals 3t squared. Looking at the other part of the integrand, the sine 2t tells us that that's g of tau is sine of 2 tau. So g of t is sine of 2t. So we know what little f and little g are. Now all we need to do is compute their Laplace transforms and multiply those together, and that's the transform of our convolution. So looking at little f of t, the Laplace transform, we'll have a 3, of course, and then the Laplace transform of t squared is 2 factorial over, excuse me, that's not t, that would be s. Okay, so let's see. Over s to the third, which would then just be 6 over s to the third. And for our g of s, capital G of s, the Laplace transform of sine 2t is 2 over s squared plus 2 squared, or s squared plus 4. So we can see then that the Laplace transform of our integral is then 6 over s cubed times 2 over s squared plus 4. And let's just combine those two into one fraction. And so that would be 12 over s cubed times the quantity s squared plus 4. So that's our first example. Let's shrink that down to a size that fits on the screen pretty well there. And let's move on to a second example now. So for our next example, let's look at the Laplace transform of the integral from 0 to t of t e to the minus 2 times t minus tau d tau. So you can see here we have the second form of the convolution that I just underlined there in black. So looking at that, we can see that the little t here is our capital, whoops, and that's not supposed to be a t, that should be a tau. So let's see if we can get that erased and fix that. Okay, so our f of tau is simply tau, and then the remainder of the integrand, the e to the negative 2 times t minus tau, that would be g of t minus tau, would be equal to e to the negative 2 t minus tau. So again, replacing t minus tau with t, we find that g of t is e to the minus 2t. So now we can take the Laplace transforms of each of those, and I'm really messing up my t's and tau's here. Actually, let's put that back. So yeah, f of tau equals tau, so f of t equals t. So then capital F of s is the Laplace transform of t, which is 1 over s squared. And then the Laplace transform of e to the minus 2t is 1 over s plus 2. Okay, so then the Laplace transform of our convolution is the product of 1 over s squared with 1 over s plus 2. And again, putting that into one fraction, we've got 1 over s squared times the quantity s plus 2. So that concludes our video on finding the Laplace transform of a convolution.